Hello, my people. Hope we're doing well. This is video 3 of the sort of unit review videos that we're doing for this first quiz for summer trigonometry. This is the third test. This is from 2012-2013 that I gave my honors pre-calc kids. You'll notice that on this one, I've shortened up the section where it's just computation, and I've elongated other portions of this test. Okay, so let's go ahead and look at this. Determine two coterminal angles, one positive and one negative, for the given angles. Be sure that your answer is given in the same units in which the problem was posed, radians to radians, degrees to degrees. Now, we've done this before. We know that we need to add 2 pi and subtract 2 pi, but when we add 2 pi, we need to do it in a rather strategic way by adding it in the form of 10 pi over 5, and we need to do the same when we subtract. We need to subtract 10 pi over 5. This winds up being 14 pi over 5, and this winds up being negative 6 pi over 5, and those are your coterminals. Now, when I'm dealing with negative 310, I know I need to add 360. And then, of course, I need to subtract 360 in order to get one positive and one negative coterminal, just like I did for the radian measurements. This becomes positive 50 degrees. This one becomes negative 670. Okay? That's one positive and one negative coterminal. Alrighty, let's go down to the complementary and supplementary. It says find, if possible, the complement and supplement of the given angle. Be sure that your answer is given in the same units in which the problem was posed. Now, pi over 6 is in the first quadrant. We can find a complement. It is less than a right angle. But a right angle is pi over 2, and it's pi over 6. Now, if you want to, in your head, think about the fact that pi over 6 is 30 degrees, and pi over 3 is 60 degrees, then you know automatically that the complement is pi over 3, okay? But you can, if you need to, transform this into 2 pi, basically pi over 6, turn this into, basically you want to figure out something that is equal to 3 pi over 6, and 3 pi over 6 is pi over 6 and 2 pi over 6, one of which reduces 2 pi over 3. Now, if you're looking for pi, you simply need 5 pi over 6 to add to your 1 pi over 6 in order to make 6 pi over 6. And done. Okay. Now we move over to the degrees, and we remember 54 degrees. 54 degrees is indeed in the first quadrant. We can find a complement. It is 6 units shy of 60, and then 30 more units shy of 90. So remember, it's 36, not 46, okay? And sometimes when we're doing arithmetic really, really quickly, we sort of make those little errors, especially for 90 degrees, because 90 degrees is so close to 100, and 46 obviously is what makes 54 into 100, but we don't need 100. We need 90, okay? So just be careful of that, and if you're the kind of person that makes arithmetic errors in your head like that, write it down, okay? Write it down. Basically, this is just shy of 60, and what we would need as a supplement to 60 would be 120, and what we need as a supplement to 54 is 126, or just, the complement plus 90 degrees. Now, it says convert the following angle measurements per instructions, radian to degrees. Okay, well, this is 3 pi over 10. We know we need to multiply by either pi over 180 or 180 over pi. It's going to be 180 degrees over pi because we recognize the fact that the pi needs to go bye-bye, okay? the 10 cancels with the 10 inside the 180, just leaving 18, and 3 times 18 is 54 degrees. Degrees to radians. I have 165 degrees times pi over 180 degrees. Now we notice that 165 is 15 shy of 180. We also know that 15 is a common factor for both 165 and 180. And if you're having a hard time seeing that, remember that 150 is 15 times 10. 165 is just 15 times 11, okay? And so if that's 15 times 11, that must be 15 times 12, since it's just one more 15, that is. And we have 11 pi over 12 as our radian measurement. Fantastic. All right, let's get to the fun stuff. On occasion, I like to write my own word problems, and they oftentimes have they're either poking fun at my colleagues or they involve medieval weaponry. This is, of course, the latter. Bob is swinging a meteor hammer, and if you can't see that picture all that well, a meteor hammer is basically a long chain, and at either end is a spiked metal ball, and you basically spin it around over your head and release it, and it does some damage if and when it hits something. So Bob is swinging a meteor hammer above his head and about to release it. Now the angular velocity with which he is swinging is 8 pi radians per second. Now remember, angular velocity is theta per time, and in this case it is 8 pi radians per second. The radius of revolution of the balls at the end of the meteor hammer is, so basically from where he grabs it to the end of the spinning meteor hammer is 15 inches, okay? So we know that the radius is 15 inches. What is the linear speed of the balls as Bob prepares to release it towards his foe? Now, we should remember that our linear speed, v, is s per time, arc length per time, which was also r theta per time, which was also r times omega. Well, we have r, we have omega. This ought to be pretty straightforward. We know that v is equal to 15 inches, and we need to multiply that by 8 pi radians per second. And you should recognize the fact that radians, as that sort of pseudo unit, is going to evaporate when you do your multiplication, and you're just going to get inches per second. Now, 8 times 15. Now, anytime you multiply anything by 8, you need to remember it's 2 cubed. So you double it a second time, and you double it a third time. So 15 becomes 30, it becomes 60, it becomes 120. What we have here is 120 pi inches per second. That, of course, if you're trying to find out, and sometimes you need decimals to give you an idea of the general magnitude of it. Now, you ought to realize that pi is roughly a little more than 3, right? And so 3 times 120 is 360. So it's somewhere probably about 380 or something like that. But if we want the exact, we go ahead and we multiply it, and I was close. And we get 376.991. Remember, always estimating the 3 decimal places, inches per second. But of course, it is asked in sentence form. We want to answer it in sentence form. So we say the linear speed of the meteor hammer is approximately 377 inches per second. Okay. And there we go. Now, instead of actually putting a full unit circle on the test, I did this for this particular year's students. I'm not going to go over this right now. This is pure memorization. You need to learn your unit circle. You need to make flashcards if that's your thing. But I'm not going to waste video time going through things that are just rote memorization. So let's go ahead and move on to the right triangle trig stuff from 4.3 and 4.4. Now, these ought to look very, 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 very familiar. Okay. And because it's basically the same template, I just saved as and just changed the values. And I did something, if I'm not mistaken, I did something very similar for y'all. Now, thankfully, this one is in another quadrant. It's -8, 15. I'm not going to do it to scale, but, you know, -8 goes in the negative x direction, then it goes up. So it's in the second quadrant. Okay, so let's call that, you know, our point, even though it's not to scale. We simply need, this is -8, this is +15. Now, 8 squared is 64. 15 squared is 225. 225 plus 64 is 289. Okay. Now, 289 happens to be 17 squared. Okay. So, we know we have an 8, 15, 17 Pythagorean triple. Okay. We have an 8, 15, 17 right triangle because 225 plus 64, 289. Okay. So this right here is 17. Well, you know, like I said before, the reason why we use a lot of Pythagorean triples is just to make the computation easier so you're not constantly spending time rationalizing denominators with really ugly radicals. But, you know, basically it doesn't really matter what the values are in order to assess whether you understand the trigonometry, right? This right here is not your theta, but it is your theta prime. It's your reference angle. And therefore, any theta that has this reference angle is going to have these three values and is going to give you the same trig ratios. So let's go ahead and do opposite over hypotenuse. That's 15 over 17. And of course, cosecant is its reciprocal. -8 over 17 is adjacent over hypotenuse. And -17 over 8 is secant, cosine's reciprocal. Tangent is going to be -15 over 8, and then cotangent is -8 over 15. Hooray! Okay, now let's go ahead and move on to 19. 19 gives me a cotangent ratio of 24 over 25. Now, if you're thinking to yourself, you know, there's a Pythagorean triple that has those values in there, right? And you'd be right. It's 7, 24, 25. The problem is that in order for a 7, 24, 25 triangle to exist, the 25 has to be the hypotenuse. And cotangent ratios are adjacent over opposite, so neither of those is the hypotenuse. So we know, it's unfortunate, but we know that that is not going to be a Pythagorean triple. And actually, this is going to be a little bit of a nasty radical. But let's go ahead and move forward with this. We know that cotangent, like tangent, is positive where sine and cosine have the same sign, S-I-G-N, right? Where sine and cosine are both positive or they're both negative. That means that it's in the first or the third quadrant, right? So this little piece of information is telling me first or third quadrant. This right here says secant is positive. Well, if secant is positive, that's where cosine is positive. Cosine is positive in the first or the fourth quadrant. Well, the quadrant which overlaps those two pieces of information is obviously the first quadrant, okay? Now, just got done telling you that that a lot of the ratios are got to be nice and neat, and then then we stumble upon this example. I was probably torturing these students because this was a particularly gifted group of students this year, and I like to throw curveballs at them just to see how they'd respond. And, you know, sometimes you just do that. Okay, so cotangent is going to be adjacent, right? There's my theta, over opposite. Now, 24 squared is 576. 25 squared is 625. And so it's actually going to be, if I'm not mistaken, 1201. But just for the sake of checking my arithmetic, since this is, you know, the third video I've done in a row, 1201, there we go. I wanted to go ahead and make sure. Even I get sort of burned out with doing mental arithmetic. Okay, so root 1201. Okay, here's the thing. I don't think I gave you anything near that monstrous on the quiz. But if I did, then just don't worry about rationalizing the denominator, or, you know, if you make a mistake, I'll overlook it or whatever. So here we just need to read these ratios right off of the triangle now that we've constructed it. And here's the thing: the actual reading of the ratios off of the triangle is not really my concern. My concern is the reasoning out of what comes before it. You know, have you reasoned correctly? Like which quadrant you're in and why? Have you labeled, based upon the ratio that you're given, the correct sides with the correct numbers? Have you accurately discerned the missing piece using the Pythagorean theorem of that particular triangle? Basically, I'm more interested the conceptual richness is in the setting up of it, not the reading the ratios off of the triangle. But that is important, okay, and we need to be able to do that with regularity. It needs to be second nature, and therefore it does enter into this, okay? Now, we have sine theta is equal to 4/7. Now, sine theta is equal to 4/7. That means sine is positive, okay? Sine is positive, of course, in 1 and 2. Cotangent is positive. Cotangent is positive in 1 and 3, okay? So if cotangent is positive and sine is positive, obviously you're in the first quadrant. Now, if we're dealing with 4/7 as a sine ratio, that is going to be the opposite. Oh, that's not writing very well. Let me get another pen. We're going to be dealing with opposite over hypotenuse. I'm not going to draw this one to scale. We're just going to go ahead and use it as a means of just plopping our information in. So this is going to be 4/7. Now remember that 7 squared is 49. 49 minus 16 is going to be 33. So this is root 33. Of course, this is our theta, or at the very least, theta prime, okay? Now, sine was 4/7. I was given that, okay? And I need to read the other 4 off of this triangle. And so I have root 33 over 7, 7 over root 33. And then I have 4 over root 33 and root 33 over 4. Okay, and I'm going to dispense with the rationalizing of the denominator because, you know, I want to make sure that I'm not completely wasting your time and filling this video with, you know, filler. So let's go ahead and move on to the next problem. I have sine as negative. Okay, I have cotangent as positive. But wait, it didn't just tell me that it was positive, it told me it was root 3. Okay, well, let's go ahead and take a look up at the instructions. It says, using identities, find the rest of the trig values for the angle. You must use identities to receive credit. Okay, well, let's go ahead and take what we have here and plug it into our little chart. Now, I know that cotangent of theta is equal to cosine of theta over sine theta. All right, I know that. Okay, well that means that just a little bit of arithmetic, or a little bit of sort of changing the form of this, I can, that's not what I wanted to do because I'm looking for cosine. I can go ahead and multiply both sides by sine and get sine theta times cotangent theta, and that is going to give me my cosine. Okay, so cosine of theta is going to be negative 1/2 times root 3, or negative root 3 over 2. Okay, now every once in a while you need to stop and check whether the answers that you are given make sense. Okay, now if sine and cosine are both negative, it totally makes sense for cotangent to be positive, right? Now, the rest of these, simply, you have to get at them by doing the reciprocal function, okay? The reciprocal identity. So basically, you know, cosecant theta is equal to 1 over sine theta, or 1 over negative 1/2, which is negative 2. Secant theta is equal to 1 over cosine theta, which is 1 over negative root 3 over 2, and that winds up being negative 2 root 3 over 3. And then, of course, tangent theta is equal to 1 over cotangent theta, which is 1 over root 3, and when you rationalize that denominator, you get root 3 over 3, and those, of course, are the remaining values. Okay, and I arrived at, that's the cosecant one up there. I arrived at all of those based upon identities, right? They're all based upon identities. This one, and this one, and this one. I had 4 remaining trig values that I needed to find, and I used 4 identities to find them. And that is what was required of me, okay? Now, the rest of this is basically just concept questions, just to kind of make sure that we're understanding everything. It says, complete the following chart detailing which quadrants correlate to which sign, S-I-G-N, for each trig function. Now, sine, okay, we know that all of these are positive in the first quadrant. So we'll just go ahead in the first quadrant. And you don't have to put Roman numerals, I'm just used to doing it that way. Now, sine is also positive in the second quadrant, and therefore so is cosecant. And by process of elimination, actually it's easier just to do it like this, so we'll just do it with Arabic numerals. Cosine is positive in the first and the fourth, and so the second and the third are negative. And of course, since it is the reciprocal of secant, and taking the reciprocal doesn't impact positive or negativeness, it is true also of those. Now, tangent is positive in the first and the third quadrant, and the reason for that is that tangent is sine over cosine. So its positiveness or negativeness depends on whether sine and cosine are both the same sign or different signs. And in the first and the third in the first quadrant, sine and cosine are both positive. In the third quadrant, they're both negative. Okay. And then, of course, second and fourth quadrant, they have opposite signs. Alrighty, let's go ahead and let's move on to this one right here. Complete the following chart by making the appropriate by marking the appropriate box detailing the symmetry of each trig function. Now, remember, the only even ones are cosine and secant. The rest are odd. And this next one basically asks what the periods are. Now, like I've said, I've decided to sort of forego talking about periods until we start talking about the graphs, and that'll be on Tuesday. We'll spend Monday just talking about transformations in general, and then on Tuesday we'll talk about the graphs, the trig graphs, and the transformations, or at least the sine and cosine graphs. But we know that tangent and if you should know that tangent and cotangent are pi. The rest of them are 2 pi. Now, the reason why tangent and cotangent are pi is because tangent and cotangent are ratios of sine and cosine. and the idea of basically it's related to this, okay? Because tangent is positive when sine and cosine are the same sign, it cycles through the period a little bit faster. And I'm hoping that'll become more evident as we construct the tangent ratio, as we just construct the tangent graph, but just sort of a heads up for that. Trigonometry is a fancy word for measurement of triangles, okay? Now, there was a lot of continuity between the three tests that we've gone over in these three videos. There was also a little bit of difference. Every once in a while, I'd like to try out different ways of asking questions. But there were a couple of things that we certainly saw were the same. There was in all three tests the same sort of computational stuff that comes from the first bit of the week. And there was also several questions on 4.3 and 4.4, the right triangle trigonometry, especially as it's anchored within the unit circle on the Cartesian plane. Okay. I am going to post along with these videos these pages as they've been worked out, but I will also post these pages clean so that if you want to work them work them and pause the video, along with it, you have the option to do so. I may post one or two other things just as sort of resources for your use if you want. But if you have any questions, as always, please do shoot me a message either by email or on Teams chat, and I will get back to you just as soon as I can. Bye.